this is going to be a really quick video to just discuss two things. The difference between UVA and UVB, and the difference between a chemical and physical SPF. So the reason that SPF is such an important thing is the protection from, initially, UVB was the first one that we knew about. Then we started learning about UVA, which did make the whole sun protection thing a little bit more complicated. So UVA, I always think of it as UVA, A stands for aging, is the one that penetrates, the ray that penetrates the deepest. They are long wave rays, and they penetrate deeper into the skin to break down collagen and elastin. That's what causes wrinkles. So when you hear skin people saying SPF is the best and first anti-aging thing, it's because the UVA rays penetrate deep into the skin, break down the collagen and elastin. That's what causes sagginess, that's what causes wrinkles. So UVA, the levels are the same all year round. In the UK, may differ slightly in different areas, but in the UK, it doesn't matter if it's sunny and July or middle of December and raining. The UVA, because it's long waves, they can penetrate through the clouds, and they are the same level all year round. So it doesn't matter what time of year it is or what the weather's like, you should be wearing SPF every day if you're worried about UVA, which you should be. So 95% of ultraviolet rays that reach the earth are UVA. And it's now believed that UVA rays can initiate the development of some skin cancers by indirectly damaging DNA and causing free radicals. So without going into a skin science wormhole, free radicals are cells that have had an oxygen molecule taken away and they're unstable, and they cause all kinds of problems. UVA can also suppress the immune response throughout the entire body and cause cells in the upper layer of the epidermis to mutate. So UVA is a problem. We're going to talk a little bit more about that when we talk about the difference between chemical and physical SPFs. UVB, so I think of B as in burning. So A, UVA, aging, UVB, burning. So UVB, you think burning, that's on your top layers of skin, so it's got a shorter wave ray, and it just really affects the upper layer of the epidermis, which is why the changes are visible, so you burn. And they do depend on the time of year. So if you go out today in January, you are much less likely to burn than if you go out, I'm sitting in London, could be different where you are, but if you go out in July, you're more likely to burn. So UVB protection is less important in the winter months. It plays a big role in skin cancer development because it really does damage your DNA. It cannot penetrate glass. So for years, everyone thought that if you drove a lot for your job, you didn't need sun protection because UVB can't penetrate glass. You can't get sunburnt, you can't get suntan through glass, but UVA can penetrate through glass. So we've all recently seen images of the truck driver who has tight non-wrinkly skin on one side, and on his window side there's a lot of wrinkles and sagging. That is UVA that can penetrate through glass. UVB is the one that can cause actual cell mutation and death, and it's more damaging to the eyes than UVA. So both of them damage vitamin A in the skin and damage collagen fibres. It's this UVA damage that means that antioxidants are really important in our skincare, but I can talk more about antioxidants. So, difference between chemical and physical SPF. This can seem really confusing. It's actually not at all. So chemical SPFs are the traditional ones that we know about. Physical SPFs are reasonably new in a sophisticated form. We all think about cricketers with really visible sunscreen, that is a physical SPF, and the reason that it wasn't used by women a lot of the time, or by people who wore makeup, is that it was very thick and reflective. That's now changed. So what happens with a chemical SPF is it penetrates the epidermis, so it penetrates the top layers of skin, to work in the skin as well as on the skin surface, and it has special chemicals in it that absorb the UVA and UVB rays that penetrate the dermis and cause damage, and it converts the rays into heat, which is then released from the body. It's rare to find a chemical that can efficiently and effectively do the deed for both UVA and UVB. So you have to mix the chemicals, you have to find what mix of chemicals work effectively together. Chemical sunscreens have been shown to give more free radical damage than a physical SPF. They're also chemicals are more likely to increase sensitivity, and it is the chemicals in sunscreen that is so damaging to the coral and to sea life, because people put their sunscreen on, they go in the sea, or they wash their sunscreen off, it goes into the water systems. So examples of chemicals to look for in a chemical SPF is avobenzene, I cannot say this, oxytin oxate, oxybenzene. So that's usually what you get. There was a question about why you can't use your body SPF on your face. The skin on your body is generally less sensitive than the skin on your face, so the chemical SPFs that you buy to put on your body will not necessarily have been checked to be okay near eyes or on the more sensitive body of your face. So quite often a few of the nice added extras that will make your skin okay with it won't have been added in for your body. Physical SPFs, as I say, they used to be very visible, very heavy on the skin, because they are either zinc or titanium based. So it's either zinc oxide or titanium oxide. So if you see that on the ingredients list, that is what the SPF is. And physical SPFs are designed to stay on the surface of the skin, and they literally are a physical block. That's why they're called the physical SPF. They are a physical block that the UVA and UVB rays can't get through, and they are effective against both. So you're not having to mix, like you have to find the chemicals that are going to do the work for the UVA and the UVB and make sure that they work together safely. Zinc oxide or titanium oxide both work. I have a slight preference for zinc oxide as it's a very healing thing for the skin. Lots of nappy creams, if you look on them, they actually say they can be used as a sunscreen or as after sun. That's because zinc is usually present and it's very healing. So physical sunscreen is ideal for kids and for people with sensitive skin. So also what can be really confusing is SPFs, the sun factor. Now you get 20, 15, 20, 30, 50, 50 plus. They're not, 30 is not 20 less than 50. SPF 30 means that about 3% of the rays get through. SPF 50 mean about 2% of the rays get through. So you can see that there's a 1% difference. So originally when the Lime Life sunscreen came out, my concern was that it was a 30 until I got my eyes on the ingredients. I would personally rather use a 30 physical SPF than a 50 chemical SPF. There's been a lot of stuff coming out recently as well to say how much damage some of the chemicals used in a chemical SPF can cause, and how easily they are absorbed into the body. So I think the more and more research goes into that, more and more people will be looking for a good physical SPF, and I, for one, love the ingredients in a Lime Life SPF. I have got one of my ingredients cheat sheets for the Lime Life SPF ingredients, if that is your jam. Just having a look at things though, obviously zinc oxide is the ingredient in there that is the SPF, that is the sunscreen. We've also got aloe leaf juice, which is great because it's very hydrating, but it also helps act as a moisture barrier. So obviously the sun and the environment can be very drying on the skin. Aloe kind of helps moisture stay in and stop it being too easily released from the skin. We've got jojoba seed oil, which is a really good antioxidant, so it's helping as well. A lot of the decisions in the ingredients for the SPF have been made to not only be the zinc oxide physical block, but also to help the skin protect itself and repair itself. So it's got niacinamide in it. Now niacinamide is fantastic. It soothes acne, it keeps skin hydrated, it helps keep a protective barrier. It slows the transfer of melanin. So melanin is what gives us a tan, and melanin is like your skin's last ditch defense against UVA and UVB. So when we think, hurrah, we're getting a tan, it's actually your skin desperately trying to protect itself from UVA and UVB damage. So niacinamide helps the transfer of melanin and pigmentation, so your skin doesn't panic. So there's lots of just lovely things in there to work really well together to soothe, protect, hydrate, and just keep the skin in really good condition. Any questions, I'm happy to answer. I hope that's been clear.